For centuries, the foundational unit of education has been the static, printed page. But for the digital native student, this model is breaking down. Traditional reading relies on a linear relationship. The author dictates the flow, pace, and exact order of the information the reader receives. Hypertext establishes the technological baseline for modern communication. It is a system distinct from printed media in both its structure and its navigational logic. A standard text block extrudes into a node graph, connecting isolated words to external images, video, and data networks through branching links. This shifts navigational power to the user. The informational hierarchy moves outward from the cursor as the reader chooses links to follow. This creates the digital reader. Instead of passively receiving a predetermined narrative, this reader actively constructs meaning by choosing their own path through the data. Teaching literature today involves guiding this hyperlinked multimodal exploration, moving beyond the simple delivery of static text. Educators now operate in an environment where texts are nonlinear, mathematically analyzable, and increasingly generated by algorithms. Digital pedagogy provides the framework for this environment, shifting the classroom focus toward interactive, learner-centric discovery. Standard online lecturing often fails to transmit the depth of a literary experience. It faces structural barriers, specifically the cultural anonymity and historical distance between a modern student and the source text. The algorithmic classroom uses a specific structural pipeline to solve these issues. It moves sequentially from raw text to hypertext to the digital reader, and finally the active learner. Within this framework, digital technology translates historical texts into a format legible to digital natives while preserving their literary essence. Remote teaching introduces baseline friction when transmitting auditory linguistic units. Standard video calls can obscure the nuances of pronunciation, stress, and language modulation essential for literary study. Automated transcription tools and live captions provide a necessary layer of digital accessibility, ensuring spoken language is captured accurately for the student. A deeper challenge exists in visualizing abstract poetic imagery across vast historical distances without a physical classroom presence. Multimedia scaffolding addresses this by anchoring abstract literary concepts in observable digital reality. Using resources like Google Arts and Culture to teach classical mythology allows students to ground the Icarus myth in specific visual representations. This enables deconstructive reading. Students analyze the text against these multiple hyperlinked visual representations to isolate mythical techniques and imagery. Transparent glassboard technologies allow educators to physically map out these digital hyperlinks, all while maintaining crucial face-to-face engagement. This mixed-mode approach requires the student to adopt active interpretation rather than passive listening. Blending audiovisual hyperlinks with traditional text creates a cognitive bridge, neutralizing the cultural and geographical isolation of the remote learner. Beyond human-guided linking, the discipline now incorporates machine-driven computational analysis. The traditional baseline of literary study is microanalysis. This method relies on the human eye performing a close reading of individual passages. Macroanalysis examines literature across vast datasets. This data grid represents a scale of reading impossible for human comprehension alone. The CLIC Dickens project uses corpus linguistics to apply this model to the digital humanities. Complex algorithms rapidly parse thousands of digitized pages to identify microscopic linguistic patterns that recur constantly throughout an author's entire body of work. The keyword in context, or KWIC, algorithm highlights a target word and instantly pulls hundreds of surrounding sentence fragments into a consolidated cluster. These concordances reorganize into a radar chart, quantifying character traits and structural patterns that remain invisible during standoff reading. Generative literature represents the endpoint of this shift, where computers produce texts according to specific dictionaries and algorithmic rules. Computer-generated poetry challenges traditional academic definitions of authorship and the human intention behind a text. When machines generate and analyze literature at scale, the humanities student's task moves towards advanced algorithmic critique. This critique moves from the generation of text into the generation of consequence, the applied ethics of autonomous systems. The MIT Moral Machine Project provides a pedagogical tool for mapping human ethical frameworks via algorithms. The project gathers its critical data by forcing users to instantly judge unavoidable, fatal crash scenarios involving autonomous, self-driving cars. The interface presents trade-offs, requiring a choice between sacrificing the passengers inside the vehicle or pedestrians in the crosswalk. This bar chart models strict utilitarianism, prioritizing the highest number of lives. However, human data rejected this. The mathematical outcome was consistently secondary to social variables. A slider graphic shows users preferring to uphold the law, prioritizing pedestrians crossing legally, regardless of group size. The results also revealed demographic biases, including the high prioritization of elderly populations and a lower valuation of fit individuals. Human morality exists as a contradictory web of social rules that resists simple computational logic. Evaluating these algorithmic dilemmas is a modern exercise in critical thinking, forcing students to confront the moral programming of future technologies. We have mapped the structural evolution from static text to the ethics of the moral machine. The digital portfolio serves as the modern replacement for the static exam. It archives hypertext modules, data clusters, and ethical reflections into a single 3D architecture. Hyperlinking classroom work transforms assessment into a continuous process of curation, creating an interconnected web of student knowledge. Success in this environment requires dual fluency, the integration of deep literary knowledge with advanced digital literacy. Generative AI and big data do not render the human educator obsolete in the humanities. These computational tools function as lenses, making complex theoretical concepts interactive and observable for the student. The human teacher functions as an essential curator, actively guiding these digital natives through a complex landscape of linked information. The algorithmic classroom creates an environment where literature is actively navigated, mathematically parsed, and ethically challenged.